So here is one example for the strong acid strong base titration, and let's see how we can calculate the pH in a different addition. 20 ml of sample of 0.2 molar HBr. HBr is a strong acid, and solution is titrated with 0.2 molar sodium hydroxide solution. Calculate the pH of the solution after the following volumes of base have been added, right? So these are the different addition conditions, and this is a strong base. So don't forget about the volume increase caused by addition of the titrant. So let's look at how we can solve this question. First example is 0 ml, means we did not added anything, so only HBr will be there. So pH of HBr means hydrobromic acid, and once it will dissociate, it will give hydrogen ion and bromide ion only, and the HBr is strong electrolyte or strong acid, that is why it will give same concentration of hydrogen ion. So hydrogen ion concentration will be equal to the acid concentration, which is 0.2 molar. Once we will take the negative log of this hydrogen ion concentration or acid concentration, we will get the pH. So pH will be 0.699. This is highly acidic, even less than 1. So HBr is very acidic, right? Now we are going to add 15 ml of 0.2 molar NaOH into HBr. See what will happen. So we are going to add 15 ml of HBr of NaOH. So before that, first we have to find out how many moles of HBr we have right now. So HBr we have 0.2 molar, which is already given 0.2 molar, and how many volume, which is 20 ml. So here we are writing in 20 ml to liters, which is 0.02 liter. So M1V1 or MAVA will be equal to 0.04 mole. So we have total mole of HBr is this much. Now we are going to add NaOH. NaOH we are adding 15 ml, and the concentration is 0.2 molar. So this multiplied by this, molarity of moles will be this much. Now you can see we have these many moles of HCl, 0.04 moles of HBr, and we have here 0.003 moles of sodium hydroxide. So we have to subtract from here to here to find out that how much excess of HBr we have. So once we will subtract, we will find out 0.001 mole of HBr we have. Now since we already added sodium hydroxide into the HBr, so we have to find out total volume. So these are the number of moles which are in excess, and how many volume. So volume was 20 ml HBr, where we added 15 ml NaOH, so total 35 ml, right? So molarity of HBr excess will be number of moles of HBr, which is 0.001 and 0.035 liter. Basically we have to write everything in the liter. Then we find out the molarity of the excess HBr, and this will be the same as a hydrogen ion concentration. So once we will know the hydrogen ion concentration, because HBr will dissociate 100%. Once we know the HBr concentration and hydrogen ion concentration, we can take negative log to get the pH. So as we add 15 ml of sodium hydroxide, you can see pH has increased from 0.699 to 1.544. Now third question was, and now third question is, if we are going to add 19.59 ml, right? So we have to do exactly same calculation. Once we are going to add 19.9, so rather than 15 ml, 0.015 liter of volume, this will be 0.0199 volume. So we have to calculate pH exactly same as we are did here, right, in the for third condition. And if we are going to add 20 ml, so let's see what happened in 20 ml. So in 20 ml means basically we are going to add number of moles will be equal, because molarity of HBr is 0.2, because here you can see 0.2 molar and 0.2 molar, and both are this monoprotic, this is monobasic, right, and both are strong, and we are adding equal volume 20 ml of acid, 20 ml of base with the equal molarity. It means they will neutralize to each other 100% and pH will be 7 neutral once we add in, which is called the equivalent point. Basically this is the equivalent point. And after that we are going to add excess of base in two conditions, 20.1 and 35 ml. So let's talk about the excess of NaOH. So 20.1 ml NaOH means the 0.0201 liter of NaOH, and moles of HBr we have already calculated from up, and moles of NaOH will be molarity multiplied by volume 0.0402 moles. So here we have excess of NaOH, right, so we have to subtract that how many moles of excess are there. So this multiply this minus this, moles of NaOH minus HBr mole. Once we will find out how many excess moles we have, which is 2 times 10 raised to minus 5 moles. And what is the volume mix? So volume mix we have 20 ml, which is 0.02 liter acid, and in which we added 0.0201 liter base. So total volume is this much, and molarity of NaOH will be moles divided by volume. Once we will know the molarity, then what? Once we know the molarity of NaOH, we can calculate the molarity of hydroxyl ion. Basically excess of NaOH means NaOH will dissociate 100% and it will give exact same amount of concentration of hydroxyl ion. So we can take the negative log of hydroxyl ion to get the POH. Once we will know the POH, we can subtract from the 14 to get the pH. So this was the next condition. Then we have added 20.1 ml of NaOH, and the last is what about the 35 ml of NaOH. So this we have to do exactly same as we did for 20.1 ml, and the pH will become 10.7. So you can see pH has increasing continuously from acid to acidic to basic conditions. So this is the way we can solve this titration equation. And if we can summarize this one, so here you can see this HBr volume was 20 ml, throughout the volume was 20 ml, moles of HBr was constant, mole of NaOH were increasing, volume of NaOH was increasing, and moles of NaOH was also increasing. Once we have excess of HBr, we have to calculate the moles of excess, total volume, then here pH this much and POH this much. POH you can find out by subtracting the 14. At equivalent point where we have the moles of HBr and moles of NaOH are equal, there is nothing excess, and total volume is 40 and pH will be 7. If we move above then equivalent point, here you can see 20.1 ml of NaOH, then basically we added excess NaOH. So once we got the excess NaOH, we will find out how many excess of hydroxyl ion there, and once we know the hydroxyl ion excess, we can take the negative log of hydroxyl ion to get the POH, and once we know the POH, we can subtract from 14 to get the pH, and same thing for the last one. So this was the one example of the titration, as we are going to increase a strong base to the strong acid, and how we can calculate the pH at different volumes.